Hey, how are you? This is Maestro Chase doing an experiment about convection currents. If you're in my class, you know that yesterday we were learning about convection currents in our science textbook, and then afterward we did an experiment. And I'd like to just review what we learned yesterday and then try the experiment, and let's see if my experiment turns out like yours did yesterday. So we began by reading in our science text about convection currents. Let me just remind you quickly of what they are. The text reads, convection currents. Even at the same height in the atmosphere, gas particles in cool air are closer together than those in warm air. This causes cool air to be heavier than an equal volume of warm air. When cool air and warm air are next to each other, the cool air will sink and force the warm air to rise. These temperature differences cause convection currents to form. A convection current is the rising and sinking of matter in a circular pattern. So let's see if you can remember what a convection current is at the end of this video. We then turn ahead in our science textbooks to look at an experiment. What causes convection currents? And we talked about the importance of making sure that we had all the materials before we began an experiment and that we read all of the steps. So let's begin with the materials. 4 cups. I have 4 cups. A graduated cylinder. Actually, I have 2 because of the timing. I want to make the video go quicker. Very warm water and room temperature water. Actually, very warm water, ice water, and room temperature water. A clear plastic tub, red and blue food coloring. A timer. Markers. In this case, we're using pencils. A ruler, and also our science study notebook so that we can observe or write down our observations. So the first step says to place the cups in 2 rows of 2. So let's do that. We'll have the warm cups there and the hot cups there. Measure 150 milliliters of warm water in each of the 2 cups on the left. So this is my left, your right. And I poured 300 milliliters in here. You know what? This is the cold water. This is the warm water. There's 300 milliliters in here because I'm going to put up approximately 150 milliliters in each cup. Now 150 milliliters in the cold cups. And I have ice in here too because we want to have ice water. So I'm going to put a little bit less water because the ice will melt and it will eventually become 150 milliliters. Okay. Pour room temperature water into the tub to a depth of 5 centimeters. I've done that. Let's check to make sure that it's 5 centimeters. It is approximately 5 centimeters. And then we're going to balance the tub on top of the cups, and let's see if we can do that right. This is a difficult step. Okay. Now we're supposed to put 4 drops of red food coloring to the left where the warm water is, and 4 drops of blue. One thing I noticed in doing my experiment this morning is that the directions also say that we're supposed to wait 5 minutes. Because our water is ice water and also pretty warm water, we're not going to wait as long. Okay, so 4 drops of red. 1, 2, 3, 4. Now some of you yesterday accidentally put in 5 drops, and so I just said put in 5 drops of blue so that it's equal. 1, 2, 3, 4. Okay. And now we are supposed to observe how the food coloring moves. I'm going to set my timer, let it go. And we're supposed to watch and see what happens with the hot water and the cold water. Remember that a convection current is a circular pattern of matter, and that cold air is going to push the hot air, or cold water is going to push the hot water up. So what do you think is going to happen? So far to me it looks like the cold water is beginning to move a little bit towards the hot water. Now, okay, now the hot water is starting to move. It's been 30 seconds. Okay, and in my book, I need to write a side view and a top view. I actually do drawings. I don't need to do any writing at this point. I'm going to use my blue pencil at 45 seconds. I think a lot of us too had difficulty keeping track of time. Okay, I'm going to move over to the camera to make sure you guys are capturing what I'm seeing here. Yeah, it looks like you are. Okay. The hot water now seems to be moving faster. It was moving slower at first. The cold water moved faster at first. Okay, we're at a minute. So what I have, actually I'll use both pencils to show. So I have hot water moving like this, and cold water moving a little bit less. That's the side view. The top view, okay, I got, looks kind of like this. Cold water seems to be kind of sitting still now. That's interesting. Why is that happening? Minute and 30 now. Why isn't the cold water moving? Why is the hot water, it seems like the hot water is being drawn to the cold water. It looks like the red dye is moving on top of the blue dye. So we're seeing that it's getting closer. Okay, now we're at 2 minutes. The red water is definitely moving much closer to the blue water. And from the top, got lots of hot water moving to, okay, now it looks like they're just beginning. Okay, I can see the blue underneath and then the hot up above. We've created a convection current. 2 minutes and 30 seconds. Let me look at the camera again, make sure you're capturing this. I think you can see it. I'm going to move back just a little bit. I think you can see that well now. Okay, 2 minutes and 45 seconds. We definitely have a convection current. Okay, 250. I'm going to do my drawing for 3 minutes now. The red water is spread almost entirely across. The blue water, or cold water, is not as far. Kind of the same at the top. Kind of see the blue. Looks all kind of mixed. 3 minutes and 15 seconds, so we're going to stop there. Okay. Now, we're not done. One of the things that happened yesterday is that we had difficulty recording our side views and top views at 1 minute, 2 minutes, 3 minutes. But then some of you even forgot to explain your results. So the question is the requirement is describe how the food coloring moved at the warm and cold ends of your model. So I'm going to say the cold water began to move first, but then seemed to stop. I wonder why. The hot water began to move slower than the cold, but then picked up speed. I observed that the hot water rose above the cold water. And then I'm going to say with an exclamation point, my experiment showed what a convection current is, exclamation point. That was fabulous. I hope that your experiment was similar to mine. If you are watching this video and have not done this experiment, or even if you have, why don't you try it at home? Hope you have a great day. Take care.